So thank you, Pradeep. Today, I'm very happy to introduce our speaker and my colleague and my friend, Dr. Hasna Mustafa. She's a principal engineer at Intel, and she's currently working on edge computing and AI solutions across IoT segments and network edge infrastructure. Previously at Intel, Hasna led car-to-cloud solutions for connected and autonomous vehicles and connectivity technologies across IoT sectors. Before joining Intel, Hasna was a senior R&D engineer at Orange in France, where she contributed to wireless network solutions for European region and led engineering efforts on video and multimedia services optimizations over wireless networks. Hasna obtained her PhD in wireless and mobile networks from Telecom Paris Tech and master's degree in distributed systems from University of Paris. I don't know exactly how to say Paris XI, so I say University of Paris. She also holds a research director qualification from University of Paris XI, the same university. Hasna is a senior member of IEEE, and she has over 80 publications in journals and international conferences, and she has books on her name, and she has over 100 filed patents. So without any further ado, let's welcome our speaker to talk about the very exciting topic of converged AI for IoT and network edge. Thank you.
Thank you, Ras. Thank you, Ras and Pradeep, for having me today, and thank you all for all the audience here. And happy to be with you today and present this topic, converged AI for IoT and network edge. And happy to have interactive discussion also. So feel free to ask your questions after each part of the presentation, and we can keep time at the end as well for more questions. That's now we speak a lot since long time we speak about edge computing, and since long time we speak about Internet of Things, and AI is there since long time. But every piece of technology was considered sort of silo. Technologies were made for IoT, mainly focusing on connectivity and focusing on low power devices for IoT compute. Network, of course, is evolving generation after generation, cellular and wireless, and AI is evolving since long time. But now we are in a very good time in technology where all the advancements helped, and also the use cases that I'll speak about, and the services and the change in the society and the requirement for more smart services made all these technologies meet and connect together, where if you see in this picture, I tried to put like some blocks and see how all is connected together. If you look at IoT and Internet of Things, of course, it needs connectivity. Without connectivity, we cannot have any IoT solution. It's Internet of Things by definition. So IoT needs connectivity. We speak about wireless connectivity. We speak about 5G now and even beyond 5G. It's not only connectivity. It started by IoT need connectivity because we need to send some data to the cloud and do analytics. But things are changing, and IoT itself is generating huge amount of data. If we look at the left-hand side here, the amount of data generated by and will be generated by IoT will reach like more than 70 zettabytes by 2025, which is a huge amount of data. Meaning what? Meaning this data cannot be processed in the cloud and cannot be processed in the IoT devices themselves. That's where the edge computing is coming, and the IoT needs not only connectivity and network, but needs edge compute as well. And statistics also show that by 2025 also, 75% of the data will be processed outside central data center. What does this mean? Meaning edge computing. So that's where the IoT is like kind of requiring network and edge computing. So we see this kind of connectedness between the different domains and different technologies. Why edge computing is needed? Edge computing is needed to enable different services that the IoT create. IoT itself, it creates mainly services for automation. When we need IoT, any IoT service you can think about, you will find that automation is one of the end goals. So automation meaning what? Meaning more processing, meaning AI, meaning I need to act on the data in an immediate way most of the time, not with a big amount of latency. So again, the need for IoT services enforces the need for 5G for reducing the latency. It can be Wi-Fi 6 also, or what beyond Wi-Fi 6, we need a kind of low latency technology, and we need edge computing as well to bear with the different amount of compute needed. If we think more of how the IoT applications are being built now. When we started with the IoT, even in research, before it comes to true deployment, we speak about connectivity technology, we speak about how the devices can connect, but we didn't think of how the application can be built for a service. So when it started, but progressively, application started as silo application. If I need to do, for example, video analytics, it's a silo application built and cannot be like distributed easily. But with the evolution of edge computing, where you can distribute your processing, microservices approach is coming, and the IoT applications themselves are built in a modular fashion, where at the application level, the service is built of a group of microservices that can be composed together to form an IoT solution that can be distributed. The solution can be distributed across multiple nodes. Some nodes can be local, some nodes can be at the network infra, some microservices can be local, some microservices can be at the network infrastructure. So that's also the sort of the IoT application itself is leveraging edge computing and network infrastructure dispatched in a network infrastructure through this microservice approach for the application. That's from an IoT side, from the left-hand side in this picture to the right. If you look at this picture from the right to the left, we have the network infrastructure, which is there and evolving generation after generation. Now we are talking 5G, and we are talking private 5G and public 5G. There are both. Private 5G is the catalyst for IoT services, meaning with private 5G, you can scale IoT deployment in smart cities, in retail stores, in manufacturing environment. It can scale easier because I will show in a coming picture, private 5G can count on on-premise deployment, which gives you all the 5G capabilities you need and the compute you need. There is, of course, private 5G. Private 5G here, there is public 5G as well. Public 5G will still serve IoT applications, but will serve applications that needs a sort of more media content, that needs like something like content delivery network, more robust infrastructure at the network access and beyond the network access level. So we see like 5G coming with private 5G and public 5G, and IoT here is benefiting from both based on the different use cases. If we look at AI from the network perspective, looking at this picture from the right to left, the network itself, the 5G, private and public, will serve the IoT. And the AI itself is needed also for the network from a different perspective. If we think of the AI for the IoT, it is for intelligent and smart applications. If we think of AI for the network, it is for intelligent network to help the IoT application to have better quality of service, to have better quality of experience. So AI is still needed in the network, but needed to automate network functions, needed to scale the network functions based on the workload that the IoT services can generate. And you have a lot of statistics here from the telco domain showing how having AI in the network for network functions automation will have a lot of benefits for the services, even for the operational cost of the network, and even for energy saving. So that's where AI is a kind of horizontal needed by IoT and needed by the network, and like to serve each other, for the network to serve the IoT services and for the IoT services to be more intelligent. If we look at the network itself, like the last part here, the infrastructure of the network itself is built by software as well. Most of the functions we are moving progressively to software-defined network functions, to cloud native. We call it cloud native network functions. Meaning what? Meaning if you look at the RAN, 5G RAN or 5G core, they are built of microservices as well. The software-defined functions for the network RAN or the network 5G core, it is built by microservices for example, the distributed unit, the central unit, or the UPF in 5G core, or the different components of 5G core. So all is microservices cloud native built. So there is a kind of commonality here. If you look at the IoT, the services, they are built in a microservices cloud native fashion. And if you look at the network services themselves, or the network functions, they are built by a cloud native microservices approach. So that's a kind of how technologies are having commonalities between them and are connected to serve, end of the day, better efficiency, more smart services. And thanks to all of those, thanks to IoT, thanks to evolution in network technologies, edge computing is part of the evolution of the network technology, and AI, of course, is taking a new era now where there are true value that is mutual value for the service and for the network that can take place. So if thinking of what I spoke, maybe having a picture can help better to try to put the thoughts on a picture. If we look at this picture, again, from left to right, you have the IoT world, and you have lot of IoT segments that can be factories, that can be retail stores, that can be health segment, transportation, e-health. More and more segments are emerging for IoT, and of course, lot of data is generated, as I mentioned, and AI is a basic requirement for any service. If you think of any IoT service, you'll find that there is AI feature existing, machine learning applied. So this thing exists, but it cannot happen on the IoT device alone by itself, again, for a huge amount of data, again, for the processing needs. That's why here is the network, which this is the network previously, like 10 years ago or so, when we think of the network, it starts from here. It starts from the access, and then after that, you have what's behind the access, aggregation, and regional data center until the network core. That was like at the time of 3G networks, for example. Now, things are evolving with edge computing, where network infrastructure is expanding to the on-premise edge. This is still a network infrastructure, but it's on-premise. It can be in a factory floor, it can be in a retail store, it can be in a roadside unit, the traffic light or the light pole of the roadside can have roadside units. That's on-premise edge, which has all the connectivity capability for 5G, plus the compute capabilities for processing data for the services and AI processing is needed. Again, the rest of the network infrastructure, whether at the access level or even beyond, like CDN, for example, or core network, compute is everywhere. Compute is everywhere, and AI processing is there. How this happens, how this dispatch and distribution happens, it's latency. It's latency expectation for the service that tells where to process the data coming from IoT devices and serving IoT services. So if you need a very, very, very low latency, then on-premise edge is the goal. If the latency can be relaxed based on the application, more far edge or more like here it's near edge can take place. Also, it depends on who is providing the service. If the telco is providing the service, telco to maximize the value of the infrastructure, the telco can host a lot of services at the access edge, at the near edge, like content delivery networks. If it's a completely new player, like an enterprise service, they can go to an on-premise edge because they can own a full network infrastructure with one box or two boxes. And we see a lot of examples now on private 5G solutions with one box or two boxes deployed in a factory, in a retail store, in an enterprise. So that's a kind of this picture shows how the network infrastructure and the IoT world are really connected. And for the reasons I mentioned, for the need of more dispatch, for the compute and processing, for the need of AI capabilities, also that cannot happen on a low-end device, but can happen on a more robust device. Sometimes there is a need for aggregation of data at a central point, collection of more data and doing processing in a centralized point. If it's traffic management in a smart road, you need to get the data from different locations and process it in a central place that can be an access edge, for example, and serve more coverage, more road coverage. So if we can tell that the AI services is converging across IoT and network infrastructure, if you look at this picture, and they can scale across different edge locations. AI also, as I mentioned, enables optimization in the network itself through automation, and I'll speak more on details, which helps the services at the end. So just one more slide, and I'll go to another part, but I'll stop for questions. That's to show you the trend even for the telecom AI. Telecom AI here doesn't mean only AI for the network, but meaning the network itself can host AI services like smart city type of services, processing happening on the network infrastructure. And also the network will be intelligent and do and use AI for automation. So that's the telecom AI. It groups both. It groups AI for the services and AI for network functions automation. So if you look here at this picture, look at the blue and the green. The red is the hardware, is the platform. That's the red. So the blue and the green. The green is the services and the software is the blue. If we look from today, for example, 2022 until 2025, more services. The green is really adding. It's more services. We will observe more services for telecom AI. And software, of course, is increasing because at a certain level, you know, between here and here, meaning the software components will be like horizontal at a certain time and serve more services due to the fact of following microservices approach, where you can have horizontal software components that can help enabling multiple services through like microservices composition. And if we look here, telco cloud revenue, again, expansion until 2025. Telco cloud meaning what? Meaning all this is the telco cloud. There is the cloud that we know, and after that you have the network infrastructure offering services, offering processing. That's the telco cloud, and revenue coming from services on the telco cloud, again, expanding. So I think I can stop. If you have any questions, then we can continue. Any questions so far? Okay. If there are no questions, we can keep.
So probably, Hasna, I think everybody understood everything that you said, you mentioned. So probably, just,
Okay.
let's take it as a positive thing. Maybe, I wanted to ask you a question like, you mentioned that, the previous way is like, the network start from the access and all. So with this edge and all, so from the customer point of view, what does it mean? And from the operator point of view, what does it mean? And overall end-to-end network point of view, what does it mean for everybody to kind of, see the picture?
Yeah, here, we're speaking here, Ras, right?
Right, right.
From the customer point of view, firstly, that's the easiest. It should be transparent. The customer needs a service. So this service, how it is deployed, the customer will care about the SLA, the service level agreement. I need this service. I need my factory to automate, for example, defects detection. If there is defects, they can be detected automatically and alerts should be sent. And I need this to happen in real time. So I don't care. As a customer, I will go whether to a telco or whether to a service provider. I want this service to happen. That's from a customer. Customer puts SLA and requirements for the services. There might be a security. I don't need the data to go out of my my region or to go out of my building, or customer has like requirements, latency, KPIs, service level agreement, and maybe security, privacy requirements.
So mostly transparent to customers, but
yeah,
a lot more to do with the operator and the vendors. Maybe you can say more about what with the operator and vendors.
Operator is lucky. Why? Because operator can play a role anywhere here. Operator, of course, they own the network infrastructure. They can leverage it the way it's better for the ROI of the network infrastructure, for promoting more services, for hosting services of others, meaning an operator can let infrastructure as a service, where anyone can bring their services and host it on the operator network. Operators themselves, they can do the on-premise edge, the private 5G, where they can create a completely private 5G network, which is separate from the rest of the infrastructure, and they sell services. They have, and it happens, we see it with private 5G. For operators, they can play anywhere in this end-to-end. What they need is support with AI. That's the point. The operators, they are not investing a lot of energy and research and so, and they are not meant to also, it's not a part of what they should do. They count on companies, other new players, new actors who come to provide the AI solution, whether AI for the network or whether intelligent services to host on top of the operator networks. So that's from an operator perspective. You asked the third point.
The vendors, like, vendors. All the companies, any vendor you want to pick, that's okay.
Vendor like the Thames.
Ericsson and Thames.
Thames here, they have also a very important role because most of the functions running, like for the access, the components, the software-defined functions for the 5G RAN or 5G core, most of the big Thames, they build it themselves. They build the RAN stack themselves, the software stack for the RAN, they build the software stack for the core. There are new vendors who come for private 5G. like Nokia and Ericsson of the world, for example, they care more about the access edge, about the public network infrastructure. When it comes to on-premise edge, you have new players who come, like we hear, not totally new, but they provide now full software stacks. We hear Radisys, we hear Mavenir, we hear Altran. They build the software stacks, the RAN and 5G core for private 5G. And they have the opportunity to inject AI in this like RAN and in this 5G core. I'll speak about the different standards that exist, because this has to follow a standard. Meaning, if I am a vendor who build a RAN solution or a 5G core solution, I cannot do the AI the way I want. I have to follow the standards in order to be interoperable. End of the day. So the vendors, they play a role also in the software stack for the network and in the AI itself that can be injected in different pieces of the network. So you see, and I'll show a table at the end showing the different players in this whole new ecosystem and how this can help, but also how this can be a challenge to get a synergy between the different players.
Thank you for that. I think it'll be it is good to know, and also maybe you can talk more about that. How AI is going to play in different part of those networks and all would be really nice to hear. Thank you.
Sure, thank you. So here I'll speak quickly about IoT and network converged use cases. Most famous use cases that we see, it needs this picture of convergence I showed. We will find that IoT services would need edge computing and would need network infrastructure, and we will see that AI is a key feature. If I go here, the famous use cases and services that we see dominant and coming and now deployed. It's not like a vision. It's in real deployment. Smart manufacturing or Industry 4.0. The factories themselves, they need automation. We see a lot of autonomous mobile robots now or autonomous guided vehicles. They start to appear in the market as products. And they started to be used in factories, in warehouses, in logistics applications. We see even static robots for automation of several tasks that can be heavy lifting. We see like video analytics, image analytics for automation of tasks like defect detection or others. So that's the smart manufacturing. We have the retail. Retail, mostly for smart stores. Most of the stores now are being transformed into smart stores. You have like, you can go to the store, you do everything, and you finish even without meeting an assistant because everything is automated. And here, video analytics and image analytics plays a big role in stores. So that's an IoT services, video analytics, image analytics. We find, of course, this service safety and security applications. It's again video analytics for safety and security. We have it in our homes. It's now going to smart cities, airports, enterprises. It's an application that will be ever going. Smart cities now, we see big potential as well. And what is the objective? Objective is reducing time on roads, helping traffic management applications through real-time monitoring of traffic, high-risk intersection, if big cities where you have high-risk intersections, you have cameras to detect pedestrian density, even controlling the traffic lights duration based on the density of roads. So most of the smart cities application is to serve roads and to offer safety. And also they are based on video analytics. Connected and autonomous vehicles, a lot of services coming from the road infrastructure to help the vehicles, safety alerts, messages, as well as a lot of mapping application, new maps for the autonomous vehicles. E-health, we see it. I'll tell you an example. The lab analytics, the lab analysis, any lab analysis or pathology. Usually it's a human intercept process. And now it's moving to an automated process where you have image analytics, very powerful image analytics for the lab analysis, which of course serves efficiency, and also it can be more accurate sometimes, and help sharing between multiple staff members easily if all is digital and digitized and automated. Immersive media is there. It's now taking different flavors. We hear about cloud gaming. We hear about AR, VR application. It is still considered an IoT application because you have an IoT device at the end, which is AR or VR headset or any device with the user. And there is a need for the network infrastructure because a huge amount of media content is uplinked and downlinked. So that's an IoT application that needs 5G, sure, and needs edge computing. But what are the requirements in general? I almost said it while speaking about every application. 5G and edge computing is needed. AI is almost a common requirement for among these applications or use cases. Image video analytics, time series data analytics, because in factories, you may also need time series data analytics, not all image or video, meaning if you can collect data like temperature, like pressure, like other data from machinery and do analytics to be able to do predictive maintenance, detect defects. Audio analytics is coming and is more and more common now. And we found a lot of AI models for natural language processing, for noise analytics. It can help safety and security. It can help entertainment application, different application. So we see it. And network analytics is coming and joining this wave again for AI for the network. And I'll speak more about it. But to tell you how things are evolving, these are the IoT services, and their requirements are, the most common requirements are those. One can ask, okay, here you're speaking IoT services, and here you're telling network analytics. Why? For the reason I mentioned before, network analytics will help automate different functions in the network, will help service keep the KPIs needed for each service. So here, every service will have more quality of service, more quality of experience. So that's the reason why it's important. Okay, here I'll speak how technologies are reacting here or are doing, or meaning all what's happening, because there are technologies that can help this to happen. So I'll focus mainly on when we say converged AI between the IoT world and the network. I'll give like a snapshot on, there are plenty of standards. If we put them all here, we need like more and more sessions. Happy to come again. But most like common standards speaking about AI here for the network, and the open source communities as well, offering implementations that anyone can use and build any solution easy way to evaluate and understand how the technologies are advancing. So starting by 3GPP, if we look at 3GPP like RAN 3, for example, it's speaking about the support of AI machine learning through a functional framework, presenting a functional framework. That's kind of example of how it looks like. You have the data collection, you have a model inference, and after that you have a sort of closed loop here happening. You have the training, the model training that should happen, and again update the inference. If you think of AI, there are two portions. There is buildings. I'll speak about it at the end, but maybe touching here a bit. You have building the model and training it with the data that you find, and after that the model is deployed. And once an AI function is happening, there is an inference, meaning analyzing and giving insights. But during the life cycle of an AI model or an AI function, there is always a follow-up on the accuracy of the model, and again, retraining happens, and again, the inference can be refreshed with updates in the model. So RAN 3 in 3GPP, they provide this sort of framework and for how AI can be applied in the network, and we need this type of functionalities. There are also, besides the framework, there is some other documents published. What they say, when we want to deploy these functions, AI functions, it can be deployed in two forms, whether the training happening in the OAM, like service management and orchestration part, for example, can host the training, and the model inference itself, the model inference itself can happen at the RAN level. That's kind of a way of deployment. Another deployment, you can have the training and inference happening at the RAN level if you do online training. Meaning what? Meaning during the operation itself, you do live training, not real-time training. This can happen for some functions. What are the main use cases here, or the motivation behind it? Energy saving, improving the energy efficiency. If AI is there to automate some functions, there can be automated sensing of power consumption. There can be prediction of workload and updating the power consumption based on the workload. Load balancing, I think all of us know about load balancing. Classically, it happens through some static rules, but with AI, load balancing can follow prediction, can happen in a dynamic way and in real time. Mobility optimization, again, all of us, when we are disconnected for mobility issues, it's a painful experience. So AI can help prediction of the UE location and the next location and handling mobility in a way to offer better connectivity. So those are like three key use cases. And as you see, it is from a telco perspective, it's oriented value for the telco, energy saving, load balancing, mobility optimization. But load balancing, mobility optimization can help the service as well. We have the SA2 in 3GPP. It brings a spec which is called NWDAF, or Network Data Analytics Function. It's mainly for data analytics, and the focus is, as you see in this picture, is on the 5G core part of the architecture. Even if it's a kind of end-to-end from a data collection point, the control itself happens in the core part, in the 5G core part. There is what? There is a collection of data from the RAN part, from the UPF on different KPIs of the network, and continuously doing analytics on these KPIs to see if there are any anomaly, if there are any improvement to be done. Improved techniques are used, like deep packet inspection in an intelligent way, traffic classification using machine learning model, and then insights can happen and a control is taken. This control can be add more network slice, for example, for the service, or expand the bandwidth for one of the network slices if one of the services KPIs is not behaving as it should be. So that's the kind of data analytics which is coming in SA2. And it's a whole list of usage here. Load level computation prediction, service experience computation, load analytics, network performance, UE behavior prediction, congestion information, quality of service sustainability, how does the quality of service sustain? Different means for gathering data and doing analytics and based on KPIs based and taking a decision to improve or to keep the needed SLA. But if you think of it, it's not end-to-end. It gets information from the RAN, but it doesn't do specific control in the RAN part. Control is coming from the 5G. There is one more 3GPP also work here, SA5. It's bringing intelligence for service assurance. Here it's service assurance. They introduce MDAF or management data analytics function. They introduce AI for the management and orchestration of the network functions, the software-defined network functions. And if you see here, they introduced like either a centralized management data analytics function or a distributed or domain-specific. Domain-specific can be, for example, for the RAN itself, or for the core network, or for specific like spot in the network, or it can be fully for PLMN wide end-to-end. And you see it's a kind of closed loop. The domain-specific MDAF can feed the centralized MDAF. So it's a closed loop assurance to help service assurance at the end. Yeah. It's not only 3GPP. I said there are plenty of standards. The ETSI itself is also looking into AI through zero-touch service management and also through the ENI or experiential networked intelligence. So zero-touch service management aims to automate all the service management. All the management and operations should be automated. The goal is to provide a network that can self-configure itself, self-monitor itself, do self-healing, self-optimization. That's something that they come up with. They are based also in AI, machine learning, closed-loop control, data collection, analytics, decision, and act. But the focus is the management and operation and orchestration. The other work, which is the ENI, again, it's focusing on the management as well, but from a different perspective. They think of a cognitive layer that can be provided and any telco can use it. And this cognitive layer can enable the telco to adjust the service offers based on the user needs, based on the business needs. And the interest they bring or the value they add, they can add this on top of any legacy system. It's not like I'm building a new network infrastructure and I'll add these functions. No, the promise is the features specified here can come with, can sit on top of a legacy network infrastructure, a brownfield deployment. One more effort within the ETSI as well, there is something called IDN, which is a framework architecture, intelligence-defined network. So again, they bring up an architecture where it has multiple layers, the infrastructure layer, control layer, and intelligent layer. And you see it's a sort of a closed loop as well. You have data coming from the user's equipment, from the network equipment. And after that, you have data analytics happening, data aggregation, and you have an intelligent layer at the end where all the data is ingested, training happens for the algorithm, then inference, then after that control to the infrastructure layer. The common pattern you will for introducing AI for the network functions is you will find a sort of closed loop automation and control as a common pattern. IEEE here is also talking about AI. Right now, the focus is from like services and society perspective. There are several efforts within the AIS or activities intelligent systems. For example, autonomous robotics ontology, which is AI and inference between the robots themselves. There are work for augmented reality. There is definitions for connected and autonomous vehicles categories, framework for deep learning evaluation. and even responsible AI. As I told you, the look here is from AI for helping services and helping the society. Responsible AI is a big topic because I'll come to the challenges at the end. How can we trust AI? When we come to network automation specifically, how can we trust the AI algorithm? How can we know that the AI is responsible? That's a big topic. So AI is, IEEE is looking into that. There is another also effort within the IEEE looking at human well-being, and there are different, like there are 3 specific efforts under this umbrella. If I go here, that's something separate. It's not 3GPP, it's not IEEE, it's not HC, but it's the ORAN. Some of us may be familiar. ORAN is the OpenRun specification, and it works in alignment with 3GPP. The 3GPP, they are defining the spec, the cellular spec, the 5G. And the ORAN is saying, I'll define the intelligence in the RAN. Right now, we are speaking OpenRun, where the RAN components, the DU and the CU can come from any vendor, and all should be interoperable, and there are defined interfaces by 3GPP to help this OpenRun ecosystem. But 3GPP is not defining the AI components in the RAN. This is happening in the ORAN, in the OpenRun spec, and it evolves with the evolution of 3GPP spec. So there are 2 main entities, RIC, or RAN Intelligent Controller. There are 2 like versions of it, or 2 components. There is near real-time RIC, near real-time RAN Intelligent Controller, and there is non-real-time RIC. And these are logical modules, software-defined modules that can sit in the network infrastructure. And as you see, the green parts are new interfaces that the ORAN specify on top of 3GPP spec. E2 interface is the interface, as you see, that connects the different RAN components to this RIC. And there is the A1 interface that connects between the near real-time RIC and non-real-time RIC. Where should they be hosted, these logical modules? Near real-time RIC is close to the DU and CU. It can be co-located with the CU or in an edge node that aggregates the CUs and have connection to the DUs. And the non-real-time RIC can be like a level like higher in the hierarchy, and ideally we see it more on service management and orchestration like SMO as a part of the SMO. The near real-time RIC, getting data, telemetry data, collecting data from the RAN, and doing real-time inference. Real-time inference for any application for the network to see how is the workload? Do we need to spin off one more CU, one more DU if the workload is high, or how to do handover or load balancing or traffic steering in an automated way? So this is a function of the near real-time RIC, collecting data from the RAN in real time and doing inference and taking decision and control to automate, to enhance. A non-real-time RIC gets data from the near real-time RIC as well as the RAN, and its goal is to train the models. Here you have the inference, and here is the training. And once the models are trained, the non-real-time RIC can help the near real-time RIC to update the model. So that's how the 2 scenarios work together, and it provides intelligence for the RAN. This intelligence for the RAN is to serve plenty of use cases, and the spec puts the exact latency required for each use case. Where to get its implementation, these logical software-defined modules, there are vendors, software vendors who build the RIC already, and also the open source community. There are open source implementation in OSC, which is ORAN Open Source Community. Another open source implementation in ONF, Open Network Foundation. So there are open source implementations. for someone who wants to build, evaluate, and test, or even for a vendor who doesn't want to start from scratch, can take the open source components and expand and commercialize. IETF is not doing nothing, but they are also working on AI. They have AI consideration as well, mainly for network management. It's coming under a research group in the IETF, Network Management Research Group. And they present, it's mainly studies on challenges, on features, on how the IETF protocol can help. The idea of a research group in the IETF, if we're not familiar, is to start studying a certain problem and a new technology emerging and feedback to the IETF working groups who owns the protocols definition to see if any of the existing protocols need to be expanded or if a new protocol needs to exist. So the Network Management Research Group looks at the gap between network management solutions and the AI solutions. What are the research challenges? They provide even a high-level framework which shows how AI with the network management can sit together. And something like this, an example, telemetry data or knowledge, this can lead to something in the IETF protocols, for example, to collect this telemetry. That's why this study is happening aside. Right now, there isn't something concrete coming to create the need for a new protocol, but my assumption by time we will observe IETF contribution protocols to help the AI in the network. Linux Foundation, that's an open source community. They have the ONAP, Open Networking Automation Platform, and it builds several components for network management, orchestration, automation. They have even an implementation for the non-real-time RIC. There is the ORAN software community. I spoke about it. When I spoke about ORAN, they build the RIC, near real-time RIC and non-real-time RIC. There is another project with the Linux Foundation, which is Edge or Akrino, where they build an edge stack that can be used to evaluate any 5G components with IoT services. And this edge stack is being tested with several edge platforms. And the Akrino project in Linux Foundation, it observes wide participation from telco, from vendors, from software providers. Everyone is contributing to build together blueprints and serve their wide evaluation. And the hope is to use these blueprints for deployment. But right now, it's a kind of mainly evaluation and test to help anyone who wants to build an edge solution. So I'll stop here. Any questions regarding standards, technologies, open source communities before I continue?
Maybe I'll ask a question, Hasna.
Sure.
Okay, all right. So the currently, the efforts are like, trying to bring something, for an example, in 3GPP, okay, the RAN 3 considered, okay, let's do some mobility and the energy efficiency and all, collect some data, have that, the loop, collecting data, find a way to collect data and improve the network, that's do you know any kind of, people are really trying such thing, or it's just the, hypothetical, putting some hooks in there only?
It's coming. I think that's a great question, because you know it, Raz, you worked a lot on this. We know it. Between standards and deployment, it takes time. But what complicates here, plenty of actors in this domain. So we need synergy, but it's coming. For the RIC, RAN Intelligent Controller, we have vendors today. We have vendors who are building RICs and working to commercialize it. So taking the spec and building it. For the NWDAF, we have also the SMO vendors, they are involved in it. It's coming, it's coming. I can give one of the examples. This one, for example, building a rig is not an issue and there are vendors, but there is a dependency on this interface, okay? The vendor who will build the rig cannot build this interface because this interface needs to come from the RAN software vendor. So there is a dependency here. If you are using the RAN, if I am a vendor having a rig and I sell it to one of the operators or multiple operators, I will tell them it will work if your RAN vendor supports these E2 interfaces. You know, that's a kind of complexity. It needs alignment between all ecosystem players and everyone builds its piece in the same time, so all the pieces can get together. But efforts are there. Usually how it works, if for a RAN vendor who's having a rig, to ensure their success, they work with, for a rig vendor, for a vendor having a rig, to ensure their success, they work with a specific RAN vendor, a partner, saying, I'll use your RAN stack, but you need to bring me the interface. It works that way. The good thing is these interfaces are open interfaces. They are not proprietary. Meaning what? Meaning if I am a telco and I have the rig and connects to a RAN, and tomorrow I need to go to another vendor, if the vendor has this interface or I need to scale, it should work. So the good point in it is most of the interfaces defined are open interfaces, are specification for interoperability, but the alignment between the multiple actors need to happen.
I see. So the ecosystem need to be developed. And any vendors themselves, you know, the base station vendors themselves doing any of these?
Some, the big ones. Yeah.
Okay, good to know. Yeah. Thank you.
You know, the problem also, so good and bad, because the idea is vendor lock-in is not desired, you know?
Right.
Vendor lock-in is not desired. That's the OpenRun. Vendor lock-in is not desired, so bringing multiple actors, it's good. But the challenge is these multiple actors need to have alignment and synergy, so the ecosystem.
So the kind of bottleneck is like the E2 need to go and connect to that here in the DU and things like that. You know, that's somebody's, you know, unless, yes, you know, DU and everything are also, you know, many vendors bring it, then it's okay. Otherwise, if you need to rely on existing one incumbent, you know, they need to open up that.
It's even more complex. Maybe what I didn't see show here, the AI applications running here in the RIC. Every AI application would need specific data from the DU.
Oh yeah, that's right. Exactly.
So again, that's the vendor. The vendor here has to make sure that they can pass this data. So, you know, it's
right. Interesting. Thank you.
Yeah. Okay. Let's talk here about, we spoke about emerging standards, open source community. What is the AI machine learning life cycle in the network itself, how it looks like, the story of multiple players, multiple actors I spoke about, and what are the challenges? We spoke about some of them while answering the questions, but if we look at it that way, a life cycle management for AI, ML in the network. Things starting by developing the model first, which is an offline process. I'm putting here color code. We have offline development, we have live deployment, and we have offline development using field data, using data from deployment. Different color codes here. So you have data collection needs to happen. If I say I want to do load balancing, I want to automate the load balancing, then we need data collection on the load, on this load in the network, and then doing analysis for this data. That's kind of data scientist doing analysis for this data, trying to see features in this data to be able to build an algorithm. Because, okay, I can do load balancing or traffic steering, but how can I analyze the data? What model will be the best model? All this is data analytics, data scientist work. And once this phase is understood, the model is built. When the model is built, it's not like go ahead and deploy, it's tune the model, get more data, tune the model, and after that, test the model. And after testing the model is still offline development, but getting data from the field. I need to test the model with true data, not simulated data. And after that, deploy it. This part is live deployment. And after deploying it, manage it. Manage this model. It's not like I'm leaving the AI feature by its own. There is a need for managing, monitoring to see the accuracy, how accurate it is. And after that, keep enhancing or keep feedback loop for continuous improvement. So if you see there is a part which is totally offline, another part which is in the field, another part still offline, but I need data from the field. That's a kind of high level. Of course, there can be deltas, but that's a high level AI machine learning life cycle management. What are the actors here in this kind of chain that we see? Multiple actors. Building AI or machine learning models or algos. That can be the network software vendor. It can be the TEM. The telcos themselves now, they started to feel that they need to be in it. They need to do it their own. They bring teams, they build new teams, AI specialists, and to help building AI models. So, but of course, it's not every telco, not every operator, but that's a trend we see. In-house applications building AI machine learning model. But still, there are plenty of software vendor here doing AI for the network. TEMs themselves, the big ones, they are doing it. AI model inference, that should happen, that cannot happen by network software vendors that during the deployment. So it's a telco. TEM can take part of it if it's something happening at the cell site also. This can happen. Data collection, the only one is the telco, because it's the telco who owns the data, which shows one of the challenges I'll speak about. The models training, the models update, it can be also telco TEM, SMO vendor, because as I showed in the ORAN diagram, the non-real-time RIC responsible for training usually sits with the SMO part. Cloud service provider, they are coming into the picture. Cloud service providers now, they are bringing AI models, machine learning models for the network, and they are hosting it as the network infrastructure. So because they have a lot of AI machine learning tools, they have a lot of experience, they want to be part of this ecosystem. There is another part I didn't show in the life cycle because this is something implicit in the background, which is regulatory compliance. Of course, this data going to the network is data of users or data of services, IoT data or others. So there are a lot of regulatory compliance. It's different from region to region regarding privacy, security, encryption. So who takes care of it? Telco, of course, is big responsible. Same for TEM or SMO vendor who consume this data through an E2 interface, for example, for a TEM, or the SMO vendor owning the training for the non-real-time RIC. Secure execution, again, those actors. So as you see, plenty of actors here, which is good, big ecosystem. But what are the challenges here? If we have all those actors, we need this to happen. What are the challenges? First challenge is the access to the data. We need real data from operational network. We work, and I'm sure most of you also in some projects or others, we work with telco. If we need data from the telco for any research, for any development, it's very hard. It's very hard for a lot of things, for proprietary, for ownership, for regulations. So meaning what? Meaning step one here is the hardest step. That's step one. So this is one of the challenges. Also, the training, once the model is developed, how it keeps training as a result of lack of true data, the vendors building the models, they use open source data. To build the model, they start by open source data available from research that can be simulated data, that can be some data sets from a project. So of course, the model will be built, that's great, but the accuracy wouldn't correspond to the accuracy needed when we have true data. One more point, and I think, Russ, you touched upon it, fragmentation and overlap in different standards. An open source initiative. I give you a kind of snapshot on a part of it, but as you see, plenty of standards, which is good, but the connectedness between the standards themselves is not there. So it can leave the one who wants to deploy to have an open question. Which standard will I follow? If I take the NWDAF, would this be operational widely, and what I develop can go widely deployed or not? Right now, the consistency is mostly between 3GPP and ORAN. They are working in a very consistent way, and there is a kind of good liaison between them. Other standards, not yet. So that's a kind of challenge. One more is the trust for AI. The telcos themselves to trust automation technologies. You know, what about if something happened and this model reacts in an odd way and I lose a part of my operational network for 1 hour, for example. So that would be a big problem for a telco. So again, this is not yet. ROI is an important thing. We speak with our partners and they ask us, you have great technologies for AI, but tell me, what is the ROI for me? How this will help me save operational cost in a quantified way if I do it and get more revenue? Of course, that's our question to answer now. Theoretically, we know. The theory says yes, but in practice, it's not yet there, the ROI. One more challenge we spoke about is the multiple actors. We have plenty of actors. How we can get them all aligned and in a timely fashion to make the deployment happen in a smooth way. So yeah, these are the challenges, lifecycle management for AI in the network. The last part that I have is some of the tools we have that can help AI, whether for IoT or for the network. Any questions first?
I think you can go to the other section too, because we are almost we have say about 15 minutes, with question and answer in case anybody have any overall questions at the end. Yeah.
So we have that's kind of Intel tools and software tools for AI and analytics. We have one API which has analytics toolkit helping data scientists mainly. There are plenty of several audience here. If, for example, if you are a data scientist building a model, then you can benefit from the analytics toolkit. It has a lot of libraries helping to build the model and in optimized way on Intel architecture. We have another part of one API, which is base toolkit. If you are building a machine learning framework, a framework for machine learning, you can leverage it. So this is a part of building. Operational, if you are deploying a model, the inference part, that's OpenVINO, and OpenVINO provides inference for multiple AI models, whether for vision and video analytics, image analytics, audio analytics, time series data analytics, even for the network AI analytics. Recently, there is a graph neural network model. So that's the kind of tools we offer and we apply in our technology building we offer to our partners. These are some details on OpenVINO itself and the different libraries we have. You will have the materials. OpenVINO it can come like you have it as an inference in a specific node in the network, or the inference can be as a service. We call it OpenVINO Model Server or OVMS. where you have a server sitting, say, some node in the network, doing the inference, and the other node sending inference requests to this server. So you don't have to have heavy compute on the nodes, but the nodes will send inference requests to the model server, and the model server will reply and give the insights after doing the inference. So this helps scalable deployment, and there is like REST API, gRPC API to communicate with the model server, which helps like interoperability. We have also other frameworks. As I mentioned, I spoke about cloud native and microservices. All is going that way. The IoT services are built in a cloud native fashion based on microservices, and the network software, the RAN and the core, they are built as well, following a cloud native microservices approach. For this to happen, you need a framework to manage and orchestrate the microservices. Kubernetes is the most common approach here and framework existing for this. We have here a software solution, Intel Smart Edge. It's based on Kubernetes, and it offers you all the optimization you need for a RAN workload, for a 5G core workload, for edge applications as well, leveraging hardware acceleration, leveraging power optimization, enabling workload management in an optimized way for whether for network workload or for edge applications. Yeah, I think I'm done. If we need to go to more questions or I emphasize other points.
Yeah, if anybody have any question, please unmute and ask any question to Hasna. I have a question, Hasna. So, in general, like, AI is making it better and things like that. We have seen it in other domains, like application domains, many, very interesting, Google and Apple, Facebook, and all have shown really good progress. But in networking here, these are good initiatives. But the thing is, the papers and things that we see have shown, okay, yeah, there is a good gain, benefit, and everything for a case or for some cases. The problem that we see is, and some of them just toy examples, some of them really with the data, but with data, less with data than, toy examples. The question is, how ready the industry to take this challenge and put that one with the AI based things are going to do well. In other words, how robust it's going to be. You touched upon the some wording that you mentioned. I cannot remember, responsible AI or something. But okay, that may be even stronger case. But just wanted to see the trust. The robustness of this thing, how it's going to work.
All is use case based. Responsible AI, of course, is a great topic when it comes to mission critical application. Mission critical application, autonomous vehicles. Why they didn't come to reality now? All the technology is there. All the technology is there, and vehicles can drive autonomously. But for responsible AI, I'll give you a simple example. If a vehicle does an accident, if I am driving now and an accident happened, we can know there is insurance company investigation, who is mistaken. But if all the vehicles are driving autonomously, who you blame? You blame the AI software vendor of vehicle A or the AI software vendor of vehicle B, or the car makers themselves who hosted the AI coming from another vendor, and so on. So that's the point of responsible AI. When it comes to mission critical, drones themselves, and even, planes now, there are a lot of companies working on small like helicopters or so without pilot. But the story, that's mission critical. The AI technology is there, but this story of responsible AI, trust. So here there is a challenge and it will take time. And it needs also alignment between different geographical location, because there are different laws. There are different laws from region to region, country to country. This makes it complicated. But when it comes to simple IoT services, retail store, when it comes to safety and security through video analytics, smart cities and giving information on traffic in the roads, even factories automation, what is your problem if something doesn't go well? You will lack efficiency, you will have less accuracy, but the ROI behind the AI is bigger than the mess that can happen. So here, you know, this thing it's already there. It's not, it's yet to come. It's already there. That's from a service perspective. From a network perspective, it will take some time. Think of it, Ras. Even I give this example. When I moved from France. I was in France. It's Paris 11. The universe.
Okay. Oh my gosh, I did not know Roman letters.
When I moved from France, it was 2012, and it was 3G networks. Okay, I came here to the US. That was 2012. I look at my mobile. I found LTE. I was so happy. And I took a screenshot and I sent to my colleagues. I said, I have LTE. My phone is connected over LTE. Meaning what? Technology was there. But from region to region, it takes time. We're speaking 5G and edge computing. So proud of all the technologies we're contributing to, but it wouldn't be everywhere all of a sudden. There are still some regions where 3G is still there. 3G is still there in some regions. So when it comes to the network, it takes time. It takes time. So bringing AI to the network will still take time, but we see the RAN. We see the OpenRun. This thing can be low-hanging fruit. We see already vendors having great deployment. We see the SMO, for example, they are building like solutions for assurance. It will gradually take place, but it's easier. Private 5G, it's controlled. It's an island of 5G infrastructure. Okay, so it's easy. It's really greenfield, and the infrastructure size is not big. So it will be progressive. All the specs that I showed here, of course, they wouldn't come to reality suddenly, but we see where is the trend based on the maturity of technology, the actors behind it who are really in advance now, and the deployment scenario, whether it's private 5G or public infrastructure.
Yeah, thank you. You know, that's a very interesting high-level perspective, and and positive attitude. Very good. Yeah. So any others have any question to Hasna?
Yeah, Hasna, just wanted to say hi and thank you. This is
Roya for
the great presentation, information. As always, it was good. Just you mentioned on the Open API and all those AI modules developed at Intel Open. I was wondering how Intel monetize this. Like, what is the business model for this?
Good question. Yeah. Right now, this software, they are not monetized. It's available. It's there. Anyone can take and deploy at the moment, as we're speaking. So they are not monetized, if you wish. They require like some license for like to work on Intel hardware also, but it's no monetization as of now for what I mentioned.
But then, is there also any plan maybe later on for the team to at least evaluate internally, or is it just for customer to debate?
No, everyone can use these tools. Everyone, yeah. Okay. Everyone can use these tools. They have their GitHub. They are open source. They are found. Yeah. It's for everyone. Yeah. It's not like internal tools. Yeah.
Sure. Okay. Thank you.
And we have plenty of IoT vendors, solution builders who use these tools to build their solutions and optimize it. Yeah.
Okay.
Thank you. Any other question? All right. So if there is no other question, almost there, time, thank you so much, Hasna,
Sure.
for, taking the effort to, put together a very nice, very comprehensive presentation on Converged AI. It's very valuable. Thank you so much for your effort and time.
Thank you, and thank you for hosting me, and thanks all the audience and the interactive discussion. Thank you so much. Thank you.
Thank you. Bye.
Have a good evening.
Thank you. Bye.
Thank you. Bye.